So here's my file. I open this in the binary editor format. I can recognize A, B, C, D, E, and F easily. So these are my A, B, C, D, E, and F. But you can see that they're actually what gets stored in the file is 0046, 0045. These are, of course, hexadecimal numbers representing those byte values. And we know that characters, raw characters, are stored in the file in a form of 2 bytes, right? So Unicode characters that we store are 2 byte size. But let's start from the other side. Write byte 65. Here it is. It's uppercase A, right? So hexadecimal 41 is uppercase A. Then we said write Boolean true. So apparently it gets stored as 0, 1 right there. Write Boolean false gets stored as 0, 0 Boolean value. Then I wrote double 3.14 and so forth, right? So that should be taking 8 bytes altogether. So let me count these 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. So these are my 8 bytes. And as you can see, those so the double takes 8 bytes. We know that this is what Java specification tells us, that doubles are 8 bytes in size. And as you can see, what follows it is my first 0041, which is the Unicode storage for uppercase A, right? So this is this 0041 right here corresponds, like right here, 0041 corresponds to this character A in the write characters. Okay, so when we write characters, we just store a raw Unicode characters in the file. So let's see how we can possibly read this information and not stumble upon anything. Just make sure that we can successfully read this information. So I'll just minimize this binary editor for now and go back to just to make sure that we can see the entire program. So let's go back to the presentation and then start thinking about the possibilities for reading this information. Now we're also going to discuss this universal transfer format for strings that Java supports, which basically allows you to store string and read string back. So that's another format, and we will have a slide that covers that. But generally speaking, this is data output interface. And so these are the methods. As you can see, these are the methods that cover all basic formats that we have to deal with this. I think there's also write long, right? I mean, there's also a 64-bit size integer. So if I said out.write, let's see if it's there, right? Yeah, here's write long. So a long integer is a 64-bit integer. So it's not very interesting to store 64-bit of an integer value. So we don't have to worry about it. I'll just not use it in my sample. Okay, so there's also a size which tells you the total number of bytes written so far using the stream, since it was output. Sometimes it's very useful for you to keep track of how much data was already output. And of course flush, as before we discussed, basically anything from memory. It's a signal to the operating system to make every effort to save the data as soon as possible, because we're using buffered I/O, and now we're asking for this to happen. But the operating system unfortunately doesn't guarantee that it happens immediately. It can still be busy doing some other things, and that's okay. We just have to accept that, because you know, we still have to deal with the behavior of the operating system. We can only ask it to be nice to us and do it as soon as possible. So here's another example, which is using an imaginary object which has the code, description, and price. and it's using here this attempt to store the entire string in the universal text format. Well, guess what? Let me actually do this. I'll go back to my project, right, and I'll do another demo. So I'll temporarily remove the append mode, making it false. I'll say no, replace the file with new data, and I will add another method right here. Write the same thing in UTF. Okay, so if I say write ABCDEF in UTF, actually I'll use the lowercase for this, ABCDEF. I'll use the lowercase version of it so we can distinguish the two, and I will just simply rerun the program, right? So just on the fly compile and run, and my Visual Studio pops up here and says the object has the data has changed, and that's okay. Let me see. Let me just see one more time. So we ran it. Let me just open this file. Open file. Just go back to my file bin and make sure I open it in binary editor and take a look at it. So here it is. So just you can see that this is using the same format. However, after the last character, so let me scroll down and make it all visible. So we just use two different methods right here, two different methods to write ABCDEF, uppercase and lowercase version of that. So let's compare it with the view of the actual content of the file. So you can see that the last F character here occupies this 0046. Okay, and so what gets stored in case of this universal format for storing strings is that instead of storing Unicode characters, this time it stores them as bytes, ABCDEF, and of course hexadecimal values for lowercase ABCDEF is 61, 62, 63, 4, 5, and 66, right? But what happens to it is at the beginning, the two bytes here basically describe the size of my string, and clearly it says 6. So yes, I'm storing 6 characters. Okay, there are 6 characters here, and it prefixes that UTF storage with those 6 characters, and it says that there will be individual bytes and they contain 6 characters. So more about that in the future to talk when we get to the corresponding slides. But perhaps this is the version of the output values that I'd like to match up and be able to write the corresponding read program that reads those values back into the program. Okay, so let's get back on track with this. So we can, you can see which classes we've used so far. So we've used in the output stream area, we use file output stream. This class associates the path to the file with an actual file object, which is responsible for low-level operations. Apparently works with the file system directly. And then obviously we've used DataOutputStream. And of course in combination with buffered output stream, which of course provides facilities to make sure that we use buffered memory when reading and writing, and in this case writing information into the file. All right, moving on. So the opposite side of things, the data input stream and the input stream interface hierarchy, just one step back. So similarly, for the output stream, which deals with raw data, there is an input stream which likewise deals with raw data and provides us a way to input the information. And of course there is the data input stream, and of course there's buffered input stream, which matches perfectly the facilities we've used to create our our output file. So that's fine. Let's see what we can do on the other side of things. So similarly, we talk here about the data input stream, which implements the data input interface. Similar arrangements to create it, and we can see that likewise it's possible to throw a file not found exception when, for instance, you try to construct the file input file and pass it the location of your file. This time we're trying to read it. It's very likely that some paths could be wrong and it should fail. So therefore, again, I can basically copy and paste this, right? Just go and say, okay, let me try this in a very similar manner. Since I already closed the output stream, I can now say, let me again try and catch my file not found exception, which I will be putting in a second. But first, I'll just kind of like, copy and paste all of this. The input objects are going to be, again, we need some extra imports just to make sure that we import everything. So here they are, input stream right there. And once again, I will do it in a similar manner. I'll declare data input stream somewhere here in the program and initialize it to null. And then I will say data input stream in basically equals this new, and I will have to specify the same type of exception. I'll simply copy and paste this catch block because I'm doing the same exact thing, right? Let's go and say source format everything. So that looks good. Obviously, I need to specify the same path to the file. It's really kind of like not a good practice to copy and paste string literals routinely in your program. So what I'm going to do is I'm just going to say Control-C copy, okay, and I'll just use some kind of private static final string, right, and just directory string and initialize it with this value just like that, right? I should spell final correctly, okay, and then I'll use this directory string instead of this, okay, so that it's more manageable this way. And then of course I will use the same directory string right here when I'm trying to work on the other side of things. This time I'm trying to demonstrate the possibility of now reading information from this file into my program and populating perhaps those primitive data types with some values. Okay, so since we know also, I'm sort of like thinking that we should be able to catch the IO exception as well. In fact, I'll just copy and paste, right? Copy and paste this entire section right here and say input read byte, but this time of course instead of specifying the value I will just say byte x byte, something like that, equals read byte. Then we're going to say read boolean value from the input, and this would be boolean I'll say x true, right, because I'm expecting true from this input right there. We'll verify whether it works or not. Another boolean x false, right, expecting to test the false input. Read boolean, so just like, it's a routine type of operation. This will be an empty set of parameters right there. Then this is my double pi equals input read double, and again, the read version of the methods do not take any parameters. Then we can say here characters. I'm assuming this needs to happen. Characters. I'm sorry. Character array. X chars characters. And I think that what I need to do is first I need to create it. I need to say new char array of 6 characters, right? Make sure that I create an array of 6 characters, and once I've done that, now I can say x characters equals. Actually, it's probably just going to allocate it for me so that I don't even have to do the new. I think all I need to do is just this, right? Just say read characters, and just it's going to. Oh no, that's not the case. Let's find out what that method call is going to look like. Yeah, so basically a read char returns a single character. Okay, so that's why this doesn't even have to be an array. I would say I'll just create a for loop. Okay, and however silly this is, but I say index, integer index equals 0, and as long as this index is less than 6, then I can say plus plus index, and do my reading inside this loop just like that. And I can populate an array of characters right here with this index value if I wanted to. And right here I'll just say char array x chars equals new char array of characters, 6 of them, right? So this way I can populate the array of characters. Okay, and write UTF has the corresponding string, x string right here equals input read UTF. So that should be easy. Okay, so that should be quite easy. So read UTF nicely just reconstructs and returns back brand new string. And then we don't have to flush anything. All we need to do is just say input close. We'll close it. And upon closing, we can do our test display of everything. So we can say system.out.print print line. Okay, and this print line will give us what? This system out.println. We can print essentially x byte, right? We can say x byte equals, just use like nice output of all of this. Display this value. Oh, I don't know what I just did. Wrong place. Let's see. X byte right there. Then we can use x true. Right, display the true. Display the true. Then we can display, just sort of like populate this. False, just verify that false is false and true is true. We can do that. Then we can display what this pi thing is. pi equals pi, then xchars, I would have to maybe I can say new string, which takes those xchars, right? I can construct the string from an array of characters. That should be not a problem to display everything. And then we can display xstring, which should be trivial to do, just display the string. And we can now test it, hopefully, right? So hopefully we'll get the same values and be successful when reading the values from the binary input stream. Okay, let's try running it. And so here you go. You can see the things that I've tried writing right here. And so these are my values. They came back as 65, true and false, and the pi value, and ABCDEF, and another version of ABCDEF. So that sort of like tells you you can create binary files, except that of course if it's good when I can use some kind of binary editor which can show me the actual bytes, and whenever it can, it tries to display the printable character equivalent of this. But if I just open just a regular text editor like this, right, the text editor here, and simply go to my file and drag and drop this file right here, see what happens. Many parts of this begin to look like garbage, right? It's just really like not something that is casually readable, and you probably be uncertain about what is exactly stored in here. So which means that both the program that writes the values and the program that reads the values have to know exactly what the format is, and the slightest mistake, if it makes, everything else is going to be just coming in as some kind of garbage. So you need to be aware of it when working with binary files, that their formats. The problem is that if this was one of my records that I wanted to store in a file, right, with information like this, then if I wanted to insert another field into this output, it's problematic, because now if I have any files that actually do store the data, now I need to write programs to convert the binary files from the old format to the new format, which essentially is a bit of a headache. It's an okay procedure, and it happens all the time, but there is now, if I need to change my code, and I already have files which contain some valuable data, then unfortunately I'm going to have to write conversion programs which read the old format and write the new format. So typically it's not an unusual task to have when you upgrade from one version of the system to another version of the system, that you need to run some kind of conversion programs which you have to execute only once in order to be able to bring up the existing application with its persistent storage to the new format. And of course, then it brings more possibilities for all kinds of problems, and you need to do some vigorous testing with the new version of the format. Make sure that no data is lost or misinterpreted. So it's one of the things that you have to be kind of careful about, because there's nothing worse that you can do than lose someone else's data. People aren't going to like it.